Yeah, hi everyone. So this video is now about achieving a desired half draft. We have done one video where we had the question of finding a desired draft forward. This is also from past question papers, and this is about achieving a desired half draft. It's based on MV Hinchip. MV Hinchip in condition number 3 sustained damage aft. To carry out inspection, the aft draft has to be reduced to 4.50 meters. Determine where will you load the cargo of 420 tons with respect to aft perpendicular to achieve this. Also determine the final forward draft. So this question is referring us to a condition in MV Hinchip stability booklet. Condition number 3. So we have to first open condition number 3 and see the data there. The aft draft has to be reduced to 4.50 meters. So this will be the final draft. After loading 420 tons of cargo, our draft aft should be 4.50 meters. So this is a known thing. Aft draft is known. So let's see this condition number 3 I have extracted here. Okay. In this condition number 3, draft aft is 4.994. And there is stream of 2.406 meter by stern. So we have to reduce the draft from 4.994 to 4.5. Our draft has to be reduced. So obviously the cargo must be loaded forward of the center of flotation. I mean, these are just the ways to know if we have make any mistake in our calculation, and by any chance our answer is coming less than LCF, it will be wrong because we may have done some mistake. Because cargo has to be loaded, because we are loading cargo. Loading will, first of all, loading will cause a sinkage, mean sinkage in the aft draft as well. So then we have to reduce the aft draft. So the cargo must be loaded forward of center of flotation. So a trimming moment by head must be created. That is just a thought you must have in your mind. So what is the initial displacement in condition number 3? 7087.3. This is the initial displacement, 7087.3. Okay. So let's proceed. I have here extracted the stability particulars, stability data for the range of draft and displacement we need in this question from the tables of Hinchip, displacement, MCTC, LCB, LCF, and the hydrostatic draft. So it will be easier for those who are watching the video to do when they're doing the question. The data is available here. So to start with, what's my initial displacement in condition number 3? We just checked and it shows 7087.3 tons in condition number 3. I have to load 420 tons of cargo. So what will be my final displacement after loading 420 tons? We add 420 to the initial displacement, 7087.3 plus 420 gives me 7507.3 tons. This is the final displacement. And all the conditions of Hinchip data, everything is always for salt water, so no question of any density correction required here. For displacement of 7507.3 tons, which is my final displacement after loading 420 tons, I enter the stability booklet of InShip and I find hydrostatic draft will be 3.955 meter. So which is right here. You can see 7507.3 will lie somewhere here. Between these two, the range of between 3.8 and 4. So I interpolate for 7507.3 and I get the hydrostatic draft 3.955 meter. Now in the same line, I will be extracting MCTC, LCB and LCF for the same displacement of 7507.3, for which I got the hydrostatic draft. And for the same displacement, final displacement, I will extract MCTC, LCB and LCF. It's all here, MCTC, LCB and LCF. So interpolate for 7507.3 displacement. The same way you interpolate it for hydrostatic draft, same way we will interpolate between for MCTC, LCB and LCF. And note down the values. MCTC 158.5, LCB 73.008, LCF 73.134. Now, this is where we now need to understand that how do we proceed for solving this question. A few minutes thought must be given before you start doing the question, so you know the clear plan. The question is telling us the aft draft required in the final condition is 4.50 meter. So 4.50 meter should be the aft draft. I just found my final hydrostatic draft after loading 420 tons is 3.955 meter. So if my ship was on even keel, the draft will be, aft draft also will be same 3.955 meter. But the required aft draft is 4.50 meter. So the difference between the two is 0.545 meter. I need to increase my aft draft by 0.545 meter more than the hydrostatic draft. So in other words, we must trim the ship by stern and my TA should be 0.545 meter. So from in hydrostatic draft, I must add TA to get the aft draft. So I must add 0.545 meter in my hydrostatic draft to get aft draft of 4.5. So in other words, 5.545 is the TA, aft trim. And we know the formula for aft trim is total trim multiplied by LCF upon LBP. If I rearrange this formula, I get total trim required T, the final trim will be TA into LBP divided by LCF. Just rearranging the same formula. So this should be my final total trim, T. TA I already know, 0.545. LBP is 143.16 for InShip. And LCF we have found for the final condition, for the final displacement is 73.134. So divide by LCF 73.134. This gives me 1.067 meter trim by stern. Okay. So in order that I should reduce my aft draft to 4.50 meter, my final trim should be 1.067 meter by stern. So initial condition number 3, the trim is more than 2 meters by stern. So we are reducing the aft trim And this should be the final trim, 1.067 meter by stern. And we know the famous formula for total trim, T is equal to LCB minus LCG into displacement upon MCTC into 100. So total trim means final trim, which is 1.067 meter. And I have LCB, I have MCTC, and I have displacement for the final condition. So if I rearrange, LCB minus LCG will be equal to total trim, this cross multiply, into MCTC into 100 divided by displacement. Total trim I require is 1.067 meter by stern. MCTC for the final condition I have already found, 158.5 into 100, and I know my final displacement 7507.3 gives me 2.253 meter. This is the LCB minus LCG. So what will be the LCG? I know LCB also. I have got the LCB also for my final displacement from the in-ship particulars. So I insert the value of LCB here. So final LCG should be LCB minus 2.253. Final LCB is 73.008 minus 2.253, and I get 70.755. This must be the final LCG of the ship after loading 420 tons. Okay, so let's make the table. Okay, original displacement, I put weight, LCG, and longitudinal moments. Original displacement straight from condition number 3, all these three values. Original displacement of condition number 3 is 7087.3, LCG 67.679, longitudinal moment 479662. This you must take straight from the condition, because condition number 3 is the initial condition, and you can see here this is condition number 3, and this is there are two columns here, LCG and longitudinal moments. Okay, so if I come down, I get here this is 67.679 is LCG, and longitudinal moments is 479662, and initial displacement is 7087.3. Okay, so this LCG and the longitudinal moments for the initial condition must be taken from the condition given in the booklet without making any change there. Okay, so 7087.3 initial displacement, LCG, longitudinal moment straight from condition number 3. Then I am loading 420 tons. LCG of this cargo, I don't know. This is what the question is all about, to find where are you going to load this cargo with respect to half perpendicular. So in other words, LCG of the cargo we need. So I just put in the X to highlight. This is what I'm trying to find. Longitudinal moment will be 420 multiplied by X, 420X. And since we are loading, so final displacement will be, you add 420 to original displacement 7507.3, and final longitudinal moments we add 479662 plus 420x. Okay, this will be the final longitudinal moments. Add the two. We know the formula for final LCG. Final LCG is always final longitudinal moments upon final displacement. And final LCG I have already found here. Final LCG required 70.755. Insert here the value of final LCG. Final longitudinal moments 479662 plus 420x divided by final displacement 7507.3. So only x is unknown here. I get the value of x. 122.66 meter is the LCG. In other words, the cargo should be loaded 122.66 meter forward of aft perpendicular, which is called LCG of the cargo. So this is the first answer. Where should I load the cargo with respect to aft perpendicular? Now they want the forward draft. Forward draft, for this I need the forward trim. TF, what will be the change in the forward draft because of trim? TF. I know TA, aft trim, and I know total trim. So total trim minus aft trim will give me forward trim. Total trim is 1.067. Aft trim TA, we have got 0.545 minus, so 0.522 meter is the forward trim required. And because the ship is trimmed by stern, so final forward draft will be hydrostatic draft minus TF because ship is trimmed by stern. So hydrostatic draft is 3.955 minus 0.522, which is TF, gives me 3.433 meters. So this will be the final forward draft. This is how is the working for questions where LCG of the cargo is required and the draft is already known. The final draft is already known. Here, the draft was known to us. It should be 4.5 meters. And in questions of where the hydrostatic particulars are known, like in ship questions, we know that we find the final forward and aft draft by applying TA and TF to the hydrostatic draft. Okay, thank you very much. If there are any comments or some doubts, you can always leave it in the comment section. So we have already done, I think, 3 or 4 questions relating to various types of trim questions, all from Hinship. So it becomes a good practice to do this question because here you have to take the data from hydrostatic table, you have to interpolate, so you get used to doing that. Right, thank you very much.